Okay, let's revisit the example. Okay, let's revisit the example. Y is the number of heads resulting from flipping a biased coin 3 times. And how biased is a coin? The chance of getting a head is 1/3. When you flip such a coin 300 times, you expect to see 100 head. And the probability mass function for Y is like this. I showed you in the last video. Okay? Now, X, on the other hand, is that the total number of heads resulting when we flip a failed coin 3 times. Pi is 50%, 1/2. Okay, 1/2. And then, when we flip the coin 3 times, X can be 0, X can be 1, X can be 2, X can be 3. And how likely X equal to 0? That chance is 1/8. How likely X is equal to 1? That chance is 3/8. How likely X equal to 2? The chance is 3/8. How likely X is 3? The chance is 1/8. Okay? Now, we have 2 random variables, X and Y. Now, when we look at the graph, and we are interested in the distribution of a single variable, how can we describe the distribution of a single variable? Okay? Describe the distribution of a variable with graph. We should look at the following. A, we should look at what? The shape of the distribution. Okay? And second one, we should look at the center of the distribution. And the next one, we should look at what? The spread of the distribution. Okay? Now, let's look at the shape first. Okay? Look at the shape. In statistics, if we find the graph with a long right tail, we call this graph is what? Right skewed. And if you find the graph with a long left tail, it's called left skewed. If we find the right tail and left tail is about the same, we call the graph is symmetric. So keep this in mind. Let's revisit the graph. Okay, let's revisit the graph here. What can you describe the first picture? I call this is what? Picture 1. And this one I call picture 2. Picture 1 is a distribution of Y. Picture 2 is a distribution of X. So how can we describe picture 1? The shape is what? The shape is, this is what? Right skewed. And this one is symmetric. Okay? Picture 1 is right skewed. And picture 2 is symmetric. Next one, how are we going to describe the center? Okay? The center, we use what? Expected value of X. Okay? Expected value of X. This number is used to describe the distribution of the center. Okay? Now, in here, you can see what's the center? In this picture, where's the center? When you hold your hand at this point, when you point your finger at this point, you can balance the graph. And that is to say EX is what? EX is what? 1.5. Okay? Now, how about EY? Let's look at the center of Y distribution. It's a little bit hard to tell, okay? It's a little bit hard to tell. But a simple argument is like this. When you move your finger along the line, the point balancer graph is a mean, okay? From that concept, you know, if you put a point, if they are not at 1, but on the right-hand side of the 1, it always gives you a feeling that this side is too heavy, okay? So you cannot balance the graph. On the other hand, if you put a point on the left-hand side of 1, no matter how close to 1, always give people a feeling that this side is too heavy, okay? So you probably can figure out after I give you those hints. The center is what? The center is 1, okay? So EY is 1. This is the expected value. Expected value of the random variable tell you the center of the distribution, okay? And how we measure the spread? The spread is measured by variance of x and variance of y, okay? This is variance of x and this is variance of y. Okay?